One was the amount of excess charge on ordinary objects. So first, the introduction and purpose of this lab was to observe interaction between charged objects in daily life. Throughout this lab, we defined forces acting on a system with a non-zero charge, and so we used principles such as Coulomb's law and the gravitational force and static equilibrium. So we estimated and calculated characteristics of the interacting objects such as mass and the forces I previously mentioned, using some observations and measurements. We also deduced other information such as number of atoms and electron deficiency or excess, based on assumptions and observations. Finally, we created a program on Python that estimates the electrical charges needed between two tapes in order for the above tape to float in static equilibrium given some initial distance between the two tapes. So let's jump in the experiments we conducted. The material we used for those was clear tape, a ruler, 2 blocks for support, a clear plastic pen, and a book cover. So the first experiments we conducted were very simple, where we had to create U-tape and approach objects to this U-tape in order to see the reaction. So we saw that there was an attractive reaction between the U-tape and the hand when we approached the hand to it, whereas if we approached two U-tapes together, there was a repulsion. As you can see in this video that I performed while doing the experiment, we can see that the two tapes repulse, which makes sense because the way they are built, those two tapes should have the same charge. In order to find what the charge of this U-tape was, we used the fact that a clear plastic pen rubbed on a cotton cloth would yield a negative charge. And when we saw that approaching the plastic pen to the U-tape caused an attractive reaction, we deduced that the U-tape was positively charged and therefore in electron deficiency. Now, question, what if the electrons had positive charge and protons had a negative charge? What would change about the observations we made? Well, if electrons had a positive charge, protons had a negative charge, the objects that were positive in our experiment would be negative and vice versa. As far as the observations and their interactions, they would be the same, because when a positive becomes negative and a negative becomes positive, the interaction is still an attraction, and vice versa. Now, floating U-tape and gravity. The second experiment wanted us to estimate the charge on a U-tape. So we approached two U-tapes in a horizontal fashion, and one was blocked by two supports until the B-tape floated in space and therefore in equilibrium. So the free body diagram on the right describes the distribution of forces onto tape B in static equilibrium. So force of gravity acts on tape B, and the electric static force of tape A acts on tape B. So we calculated by using an assumption for the distribution of mass on the tape. We calculated the gravitational force to be approximately 0.02 newtons on tape B, and the distance at which tape B starts floating when we approach tape A we found to be 8 millimeters. So we then used Coulomb's law, which you see under the free body diagram, to solve for the charge of tape B, since the force of gravity and the electric force compensate because of equilibrium. And we found this charge to be 1.2 10 to the negative 8 coulomb. Then we calculated the electron deficiency of the atoms in the tape. So we found that there were 4 10 to the positive 8 atoms in our 20 centimeters of tape, and that the total number of deficient electrons per atom was 185. We first used the total charge divided by the elementary charge to find the number of electrons missing in the tape, and then we divided this value by the number of atoms in the tape. Next question, why is it important to handle the charged tapes as little as possible? Well, it is important because when tape comes in contact with hands or other objects, charges might be exchanged, hence changing the total charges of the objects and polluting or interfering with the potential result we would have obtained without this contamination. So finally, the Python program. I will show you a demonstration of what my program yields. And so this is what the program yields, where you can see the two particles which represent the tapes and the necessary charge that those should have in order to be in equilibrium in space. So to conclude on this lab, we saw that while relying on some assumptions, it is possible to estimate the charges of common objects by simple observations and measurements, and the application of physics laws and principles such as Coulomb's law and equilibrium.